Hello everyone, in this video I am going to explain IUPAC nomenclature of aldehydes and ketones. IUPAC nomenclature of carbonyl compounds. So what are carbonyl compounds? Aldehydes and ketones are collectively said to be carbonyl compounds, right? So some rules to write IUPAC names of aldehydes and ketone. First, aldehydes. The organic compounds containing CHO functional group. CHO functional group are called as aldehydes. Organic compounds containing CHO functional group are called as aldehydes. Secondary suffix for aldo group, CHO group, CHO functional group is Al, all or otherwise carbaldehyde. We use these two different secondary suffixes in different condition. General formula of aldehydes is RCHO. What is general formula of aldehyde? RCHO. Aldehydes denoted with RCHO. Just like alcohols denoted with ROH, aldehydes denoted with RCHO. Molecular formula of aldehydes is CnH2nO, whereas molecular formula of alcohols and ethers is CnH2n plus 2O. Here CnH2nO. Next, general IUPAC name is alk root word, meth, ith, prop, but, pent, like that. Then primary suffix ane, in, ein, suitable primary suffix. If single bonds are present, we use primary suffix ane, double bonds in, triple bond ein. Here secondary suffix, if you use secondary suffix all, then remove e from the last from the primary suffix, because here all beginning with al all beginning with vowel a, that's why remove e from this one. If you use carbaldehyde, no need to remove last letter e, because carbaldehyde begin with consonant c. Okay, c to if it is beginning with C, no need to remove E. If it is beginning with A, you have to remove E. Next, see this note is important. If carbon atom of functional group taken into parent chain, then use secondary suffix all. So there are two suffixes for it. When will we use Al, all secondary suffix for aldo group? When carbon atom of functional group taken into parent chain, counted into parent chain, in such cases we have to use secondary suffix all. If carbon atom of functional group cannot be taken into parent chain, it is not possible to take that carbon atom of functional group into parent chain, we cannot count it. In such cases we use secondary suffix carbaldehyde. There are two suffixes for aldo group, one is Al, all, two is carbaldehyde. Take a screenshot. I am going to give some example. Next. Examples. If functional group is aldo group with one carbon atom, like this. How many carbon atoms here? Only one carbon atom, so we use root word meth. In this case, you have to use ane, secondary primary suffix ane. because there is no other carbon to say that is double bond. This is ane. Next, if double bond present between carbon and oxygen, we do not use ene. If double bond between carbon and carbon, we use ene. So ane. There is no other carbon, so ane. Next, functional group is CHO group. Whenever functional group is CHO group, we use Al, all. Here, all beginning with vowel, so remove E here. Remove E and write total name. Meth plus ane plus all. Methanol is the name of formaldehyde. Name of this molecule. Common name is formaldehyde. Formaldehyde is common name of HCHO. Formaldehyde or formalin. Formaldehyde or formalin. Formaldehyde or formalin. Next, second one, CH3 CHO. CH3 CHO. Count number of carbon atoms here, 2. Use root word ith. Between those two carbon atoms, single bond, so write ane. Then CHO functional group, so CHO functional group, this carbon taken into parent chain, use all. Remove E plus and add all. This become eth plus ane plus all. For alcohol, methanol, ethanol. For aldehydes, methanol, ethanol, like that. Common name for ethanol is acetaldehyde. Common name for aldehyde, acetaldehyde. Next, if I write bond line formula like this, how many carbon atom? This carbon, this carbon, this carbon, total 3 carbon. So root word is pro. Between those 3 carbon atoms, single bond. Ane, remove E. Whenever CHO group appear, write Al, all, total, propanol. Propanol or propanaldehyde. So this is also called as ethanaldehyde. This is propanaldehyde. Propanaldehyde. If it is propanaldehyde, this is ethanaldehyde, but acetaldehyde is very familiar when compared to ethanaldehyde. Acetaldehyde is more favorable, more familiar when compared to ethanaldehyde. So I have written acetaldehyde. So next, if you write like this, then count number of carbon. This is carbon or not? Yes, this is carbon. 1, 2, 3, 4. 4 carbon atoms. So but single bond between those 4 carbon atoms. So ane, remove E, CHO functional group. So all. But plus ane plus all. Butanol. Common name is butanaldehyde. Common name is butanaldehyde. So if or I am completely writing CH3 CH double bond CH single bond CHO. For this 1, 2, 3, 4 carbon atom, root word is but. For 4 carbon atom, root word but. So numbering, definitely functional group should get lowest possible number, that is 1 is possible here, 1. On second carbon, double bond, 2 ene, and CHO functional group is present. So all. Remove E plus and add all. But 2 ene, remove E and add all. But 2 enol. The common name for but 2 enol is crotonaldehyde. Crotonaldehyde. Crotonaldehyde is but 2 enol. Common name for but 2 enol is crotonaldehyde. Crotonaldehyde. Next. If phenyl group is present, what is the IUPAC name of this molecule? Count number of carbon atom. 1, 2, 3. This cyclic chain contains 6 carbon atom, open chain contains 3 carbon atom. But due to presence of this functional group, this should take into parent chain. This becomes substituent. Even though it contains more number of carbon atom than open chain, due to presence of this functional group present in open chain, that should be taken into parent chain. Then this becomes substituent. What is substituent? Phenyl. At which position? Third position. 3 phenyl, 3 carbon atom. So prop, 2ene, CHO group. So all. 3 phenyl prop 2enol. 3 phenyl prop 2enol is IUPAC name of this molecule. This is commonly known as cinnamaldehyde. Common name for molecule is cinnamaldehyde. Common name in bracket. Okay, right. Next, if molecule is CHO and CHO, here count number of carbon atoms 2. So root word is eth. Between those 2 carbon atoms single bond, so ane. 2 CHO groups are present, so diol. Ethane, diol. Ethane, eth plus ane, ethane, diol. Ethane, diol. But common name is familiar, that is glyoxal. What is the common name for this molecule? Glyoxal. This is what? Glyoxal. Next, if molecule is like this, for this molecule, how do you write name? 1, 2, 3 carbon atoms. So root word is prop. Between those 3 carbon atoms single bond, so ane. Due to presence of 2 CHO groups, we use diol. At which position? First and 3. 1, 3, diol. Propane, 1, 3, diol is the IUPAC name of this molecule. Take a screenshot. I am going to give some more important examples. If molecule this one, for this molecule number of carbon atom 1, 2, 3, 4, 5, 6. This is also same, CHO group, this is CHO group, this is CHO group. If possible, take all functional groups into parent chain, otherwise remove all functional groups from the parent chain. Here this point. If possible, take all functional groups into parent chain. Taking all functional groups into parent chain is not possible. In such case, leave all functional group. Omit all functional group while counting parent chain, while taking parent chain. So here 1, 2, 3, 4, 5. This carbon, this functional group not possible to take into parent chain. That's why remove all these 3 because all are aldo groups. You cannot remove 1 from parent chain. If you want to add, if possible, add 3 functional groups into parent chain. Otherwise, leave 3 functional groups from the parent chain. So taking this into parent chain is not possible. Taking this second CH4. That is why I am neglecting all these 3 functional groups from the parent chain. So then parent chain become only this one. Now how many carbon atoms here? 3 carbon atom in the parent chain. So what is root word? Pro. Plus between those 3 carbon atoms single bond in plus whenever carbon atom of CHO functional group not counted in the parent chain, not taken into parent chain, then use secondary suffix carbaldehyde. If this carbon counted in the parent chain, we use Al all. If this carbon not counted in the parent chain, we use secondary suffix carbaldehyde. Carbaldehyde for 3 times. At which position? First position, second position, third position. 3 times, so tricarbaldehyde. So propane, 1, 2, 3, tricarbaldehyde. No need to remove E because next letter is T. T is not vowel, this is consonant. Tricarbaldehyde. Okay. Next. Taking next example. CH2, CHO, next CH2, CHO, here CH2, CHO. Selection of parent chain 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All are same. This one both are same. So if these 2 are CH2H, CH2, CHO, CH2, CH2, both are same. So I am taking 1 as parent chain, considering 1 into parent chain, 1, 2, 3, 4, 5. Okay, by taking these 2 into parent chain, you can ask me, how can you neglect this CHO? By counting these 2 into parent chain, how can we neglecting this CHO? See this CHO is not directly attached with parent chain. Between parent chain and functional group, some other carbon CH2 is present. In this case, you can neglect this one. So if 3 functional groups, 3 CHO groups directly attached to parent chain, then you cannot neglect anyone like this. 3 CHO groups attached to parent chain, you cannot neglect 1 from 3. But here, this attached to parent chain, this functional group attached to parent chain, this is not attached to parent chain. See, this is our parent chain. In this parent chain, this is attached to parent chain, this attached to, in the part of parent chain, this in the part of parent chain. This is not directly attached with parent chain. Between parent chain and functional group, some other group is there, CH2 group. That's why you can neglect this one. Now, count number of carbon atom, 5 carbon atom. So root word is pent. Root word is pent. Between those 5 carbon atoms, single bond, so ane. Primary suffix completed. Next, due to presence of 2 CHO groups and they have taken into parent chain. That's why use all. If the carbon atoms of functional group are counted, then take all 2 times at first and 5th position, diol. Pentane 1, 5 diol. And what about this? This is what? This is parent chain. This is substituent. So which substituent? If it is CH3, we write methyl. If it is CHO, we write formyl. Both are present. Formyl attached to methyl. Formyl methyl at 3rd position. 3 formyl methyl. So this is, if it is CH3, we write methyl. Formyl group attached to methyl. Formyl methyl at third position. So 3-formyl methyl. 3-formyl methyl. 3-formyl methyl pentane 1,5 diol. So by adding all those, you get IUPAC name of that molecule. Hope you understood well. Next, continuation, taking next example. If molecule is like this. So here number of carbon atoms are 1, 2, 3. So this is only functional group. Whenever functional group is directly attached with ring, when directly attached with ring, when functional group CHO, when CHO group directly attached to cyclic chain, then its secondary suffix, CHO secondary suffix is carbaldehyde. Then what will be the secondary suffix? Carbaldehyde is secondary suffix for that. So this is carbaldehyde, that means no need to take into parent chain. Then give number, this is parent chain, 1, 2, 3 is, this is parent chain. How do you write its IUPAC name? 1, 2, 3 carbon atoms. So those 3 carbon atoms in a cycle. So first primary suffix, primary prefix cyclo plus 3 carbon atoms are there. So prop, between those 3 carbon atoms single bond. So ane, CHO group is present. So carbaldehyde plus carbaldehyde. So what is cyclo? Cyclo is primary prefix, prop is root word, and ane is primary suffix, carbaldehyde is secondary suffix. సో ఎవరైనా డైరెక్ట్ ఈ క్లాస్ చూస్తే అర్థం అవ్వకపోతే సో ఐయుపిఎస్సి నామన్క్లేచర్లో బేసిక్ వీడియోస్ ఉంటాయి, బిగినింగ్ నుంచి చూస్తే మీకు అర్థమవుతుంది. రైట్. సో సైక్లోప్రోపేన్ కార్బాల్డిహైడ్ is IUPAC name of that molecule. Next example, see this. Right, here which one is the parent chain? Cycle or open chain? Here cycle is not parent chain, open chain become parent chain because CHO group not directly attached with, when CHO group directly attached with cycle, but here what? CHO group not directly attached with cycle, in between those two CH2 is present, so this one become parent chain, this is not. So CHO group if directly attached with cyclic chain, then use carbaldehyde. If CHO group not directly attached with cyclic chain, do not use carbaldehyde. This become all. This become all mean this carbon should taken into parent chain. Whenever that carbon should taken into parent chain, numbering functional group carbon must be 1 and this is 2. What is IUPAC name? IUPAC name is 2 carbon atoms. So eth, between those 2 carbon atoms single bond ane, ethane, CHO group is present and carbon taken into parent chain. So all. Ethanol, 2-cyclopropyl, 2-cyclopropyl ethanol is IUPAC name of this molecule. Next. CHO group is directly attached to cyclic chain, so carbaldehyde. cyclopentane carbaldehyde. Cyclopentane carbaldehyde. For cyclopentane group, substituents are like this. Then, so whenever CHO group directly attached with a cyclic chain, use carbaldehyde, do not take into parent chain. Do not take into parent chain. Then this chain become parent chain. 1, 2, 3. 1, 2, 3. Do you give priority to methylidine group or ethylene group? We definitely give priority to ethylene group because ethylene beginning with letter E, methylidine beginning with letter M. In alphabet, E comes first. So, what is the IUPAC name of this molecule? First substituents name 3-ethyl 4-methylidine 3-ethyl 4-methylidine. This is what? Cyclopentane carbaldehyde. Cyclopentane carbaldehyde. This is the IUPAC name of this molecule. Okay. Next, take a screenshot. I am going to give 2 more examples. Fourteenth one. For this molecule, here CHO group directly attached to cyclic chain. Both CHO groups are directly attached with cyclic chain. In that cases, use secondary suffix carbaldehyde. Using secondary suffix carbaldehyde means we are not counting carbon atom of CHO group into parent chain. So this is not parent chain, this is not parent chain. That means what is parent chain? 1, 2, 3, 4, 5, 6. Cyclohexane, that become parent chain. What is root word? 6 carbon atoms are present. So hex, between those carbon atoms single bond. So ane at first position and fourth position 2 times carbaldehyde. We do not write all because CHO group directly attached to cyclic chain. Carbaldehyde. Hexane 1,4 dicarbaldehyde is IUPAC name of this molecule. If you find this molecule, if you are asked to write IUPAC name of this molecule, then so this is open chain contain 1 carbon, this is closed chain contain 6 carbon atom, both containing functional group. This one containing functional group, this one also containing functional group. So 1, 2, 3, 4, 5, 6. At second position substituent, 1,4 positions functional group. Why this becomes substituent? This is not CHO, this is not directly attached with this one. This is substituent, methyl is substituent. At second position methyl. So in methyl 1 hydrogen replaced by CHO. Formyl methyl is substituent here. So these two are functional group. Then what is the IUPAC name? 2-formyl methyl cyclohexane 1,4 dicarbaldehyde. This is the IUPAC name of this molecule. So in this way we write IUPAC name of aldehydes. Take a screenshot In this video, I am continuing with IUPAC nomenclature of ketone. IUPAC nomenclature of ketones. Take this as screenshot. So I will write all the points regarding ketone. Then I will continue this one. Next, IUPAC nomenclature of ketones. So organic compounds containing C double bond O functional group. It is a bivalent functional group. On both sides carbon chain is attached. Bivalent functional group. So organic compound containing C double bond O functional group is called as ketone. Next, organic compound containing C double bond O functional group is called as ketone. Secondary suffix for ketone functional group is ONE, on. There is no other secondary suffix like for aldehydes AL, all, and carbaldehyde, two secondary suffixes, but here only one secondary suffix. General formula of ketones is R C double bond O R. For aldehydes R C double bond O H. Here R C double bond O R. Next, molecular formula of ketones is CnH2nO. For aldehydes also same. Molecular formula for aldehydes is CnH2nO. For ketones also same. For aldehydes and ethers, same molecular formula CnH2n plus 2O. That means those two are isomers. Aldehydes and alcohols and ethers. For alcohols, ethers, same molecular formula CnH2n plus 2O. That means alcohols and ethers are functional group isomers. For aldehydes and ketones also same molecular formula CnH2nO. Same molecular formula. That's why these two also, I mean aldehydes and ketones also functional group isomers. This topic we will discuss in isomerism topic. Isomerism. Next, general IUPAC name of ketone is alk root word, meth, eth, prop, but like that. If single bonds present, we use ane. Double bonds present, we use ene. If triple bonds are present, we use ine. Next, secondary suffix on, that's why remove last letter E from primary suffix. Thus we get alkanone, alkenone, alkynone, like that. Okay. Take a screenshot. I am giving example. I am going to give examples. Only few examples. Since ketone is bivalent functional group, on both sides must be carbon. That means minimum 3 carbon atoms are present in ketone. Due to presence of 3 carbon atom, what is the root word? Prop. Between those 3 carbon atom, don't compare with oxygen or nitrogen, anything. But you need to see between carbon atom, single bond. So use ane. Next, whenever C double bond O group appear, C double bond O group on both sides alkyl group. C double bond O group appear with both sides alkyl group, we use on. Here on is beginning with vowel, that's why remove E here. Then it become what? Propanone. Prop plus ane plus on. Propanone is the IUPAC name of this molecule. For propanone there is a common name important that is acetone. Acetone. Acetone is solvent for nail paint, that's why used as nail paint remover, nail polish remover. Next, second one, CH3, CH2, C double bond O, CH3. For this molecule 1, 2, 3, 4 carbon atoms, so but between those 4 carbon atoms single bond, so ane, remove E and O. No need to mention the position of C double bond O because if you put C double bond O here, we use number 2. If present at this one, we give number from right to left. That always takes second position. So always takes second position. There is no chance for other position. That's why no need to mention number. Butane plus one. Butanone. Butanone is IUPAC name of this molecule. Next. For this one, count number of carbon atom 1, 2, 3, 4, 5 carbon atoms. So pent. Between those 5 carbon atoms single bond. So N, remove E. Double bond position is required here because there is another ketone with 5 carbon atom. That is, if I take like this 5 carbon atom 1, 2, 3, 4, 5 like this, but position of functional group is third position. This is second position. If you write pentanone, this is also pentanone. This is pentanone. If you do not mention double bond position, on. Pentanone, this will also become pentanone. Both are same. That's why you need to give clarity. This is pentane, pent plus ane, 2 on. Position of keto group is second position. Pentane, 2 on. Pentane 2-on is IUPAC name. Here for this molecule, pentane, pent plus ane minus E, third position on. Pentane, remove E because secondary suffix beginning with vowel, on. Pentane 3-on. Pentane 3-on is IUPAC name. Next. See this example. Count number of carbon atom 1, 2, 3, 4, 5. 5 carbon atoms. So pent ane 1, 1, 2, 3, 4, 5. Give number like that. Then 1, 4. Sorry, 2, 4. I will give number with green marker 1, 2, 3, 4, 5. Then that become pentane 2, 4 dione is IUPAC name of this molecule. Okay, only for this one common name important, acetone. Acetone is common now. Next, sixth one. If you see molecule like this, for this molecule, how do you write? So cyclo is primary prefix, pent is root word, ane between those 5 carbon atoms single bond. So ane, on, remove E plus on. No need to mention position because this always become 1. If you put here, this is 1. If you put double bond here, this is 1. So what is the IUPAC name of this molecule? Cyclopentanone. Cyclopentanone. And lastly this one. One example, just I want to give only one example. So if this is CHO group, and here C double bond O group, and here nitro group or anything. How do you give number? So this is definitely 1. Give number to double bond or substituent. Which one is more prior? Double bond is more priority when compared to substituents like halo, fluoro, chloro, bromo, iodo, nitro, alkyl groups. Alkyl groups, nitro group, halo group, all these are substituent. Double bond is always more prior than those substituents. So give double bond most priority than NO2 group. And this become 5 nitro, cyclo, 5 carbon atom pent, 2 ene, 1 on is the IUPAC name of this molecule. 2 ene, 1 on. 5 nitro, cyclo, pent, 2 ene, 1 on is IUPAC name of this molecule. Okay, thank you everyone. If you like this video, just give a thumbs up, just like my video, and if you trust this one is useful for JEE mains and NEET MSET aspirants, just share to them. This is my request. Thank you.